Resistors are devices which offer resistances. So here we can actually combine two or more resistors in different ways to get the desired value of potential difference and current. The two major ways of connecting resistors are series combination of resistors and parallel combination of resistors. Here we are going to discuss about series combination of resistors. Series combination of resistors means it is an end-to-end connection of resistor, and in this connection of resistor, if you look at the diagram, the circuit diagram that is given below, you will have three resistors R1, R2 and R3 connected in such a way that if a current flows through it, it has only one way to go. Why it is called end-to-end? Because one end of resistance R1 goes to one end of resistor R2. The other end of resistor R2 goes to the one end of resistor R3. So this is what is meant by end-to-end connection. For having a similarity between this type of a connection, you may recall the connection of a series which you use in Diwali lighting. The bulbs are connected end-to-end, and that is what is called as a series connection. Now, what exactly happens in a series combination of resistors? Here, this is a proper circuit showing a series combination of three resistors R1, R2 and R3. Now, these three resistors are connected in such a way that when you connect a battery across it, the current will flow from the positive to the negative terminal. So the current will have only one way to go. The same amount of current will be flowing through R1, R2 and R3 irrespective of the values of resistance. That means even if the three values are different, they will all allow the same current to pass through it. How is it possible? It is possible because the potential difference which is applied across the combination, that is, I have written it as point X and Y, across which a voltmeter is connected. So the potential difference across this X and Y gets divided across R1, R2 and R3 so that the same current can flow through R1 and 2 and R3. Now if you look at the circuit diagram, there is an ammeter connected in series, voltmeter connected in parallel, and the current is passing through the main circuit which is given as I. There is a key connected. So since the potential difference is divided across R1, R2 and R3, I can say that the total potential difference across the combination, that is which is given by V, will be a summation of V1, V2 and V3. So V can be written as V1 plus V2 plus V3. Now if we are able to replace all the three by a single resistance Rs, such that the potential difference across it will be V and the current flowing through it will remain the same I, then when you apply the Ohm's law to the entire circuit, we can write V is equal to IRS. What is RS? RS is the equivalent resistance of the combination. So we have to find out what is the relation between RS, R1, R2 and R3. Now if you individually apply the Ohm's law to each of the resistance, then we can write V1 is equal to IR1, V2 is equal to IR2 and V3 is equal to IR3. So if you look here, we have applied Ohm's law to individual resistances, and we will see that V1 is equal to IR1, V2 is equal to IR2, V3 is equal to IR3, where V1, V2 and V3 are the potential differences across R1, R2 and R3. Now by using these two equations and the second ones, that is 1, 2 and 3, instead of V I put IRS, instead of V1 I put IR1, and similarly instead of V2 and V3 we put the value of IR2 and IR3. We get the result as IRS is equal to IR1 plus IR2 plus IR3. You take I common, within the bracket it will be R1 plus R2 plus R3. So RS will be equal to R1 plus R2 plus R3, which basically brings us to a conclusion that when you have two or more resistors connected in series, the total resistance offered in the circuit increases, and thereby the current is going to decrease. So if you want an increase in the resistance in the circuit, then you can connect the resistors in series, whereby you can decrease the amount of current flowing through the circuit. So this is the mathematical expression for the series combination of resistors, which is written as Rs is equal to R1 plus R2 plus R3.